Okay, so we'll quickly run through this Welsh Computer Science Board paper. I'll do it off the top of my head, so if I make a few mistakes along the way, I'll try and explain where I'm going wrong or what I think about the question. I don't want to make it too boring. Just, let's get to it. So, which four of the following items are protocols? Oh, this is the 2016 paper. I've just downloaded it now. Right, so protocols. First of all, the way I tackle these exams is I've got to know what all these mean first. So I know IP is Internet Protocol. So that's one of them. It's got to be. ISP is Internet Service Provider, so that won't be one of them. P2P is usually peer-to-peer, so that's not going to be one of them. TCP is Transmissions Communications Protocol, I forgot, but I know that's a protocol because usually it's TCP IP with it. So it's that one so far, that one so far. LAN is Local Area Network. Nope. HTTP is Hypertext Transfer Protocol. So that's one. File Transfer Protocol, that's what you use to build websites. And ROM is read-only memory. So for me it's that one, that one, that one, and that one. I think that'll be right because those aren't protocols, the rest of them. Right, next one. Name four components of the central processing unit and describe the function of each named component. Right, okay. There's loads of things you can have here. So, component one, central processing unit. The most obvious one, I think, would be cache. So, component one is cache, and function it's memory located close to the processor for fast retrieval of like instantaneous saving done by the processor. It's small, it's not very big, but it's located close to the processor for speed, things just loading really quick. Component 2, I'd have to say the ALU. So I think it stands for the arithmetic logic unit, and basically that does all the operations in the computer. You need that, because next to it is the CU, the control unit. I suppose you could have that here. Control unit. You could have buses. Buses are the connections between all of the components on the motherboard. And you could have, or did I say register? Because the registers were information stored, and registers are usually faster to access than any kind of internal memory. I can't think of anything else, so I would go with cache, memory located near the processor for fast retrieval. I'd have ALU, it's the arithmetic logic unit, I think it stands for, and that's for doing all the calculations over the processor and the computer itself. I'd have a bus. This is the thing what connects all of the components. I think there's a few buses like control bus and address bus. I forgot, but basically doing a Google search on this and you'll be golden with that because it's not changed for years. And the last one, I said register. So you could have register. It's just faster retrievals, better than using actual memory. CU control unit. Yeah, I'd be stuck with naming four of them. It's been a while since I've done that theory, but I think I've nailed it. Yeah, ALU, register, cache, and bus. And yeah, we explained them. Right, so state the purpose of hardware ports. Given an example of a hardware port. Right, a hardware port is, if you look at the back of your computer, you've got loads of things what can go in it. You've got the HDMI port, you've got the USB port, you've got the Ethernet, you've got your printer port, which I think is called a serial port, and your PS2 port if you've got an old style computer, because now it's all USB, but PS2 ports were for the old mice with the little pins on it. So that's the example of a port, so HDMI, USB, Ethernet, PS2, and the purpose of the port is to connect those kind of devices. So say the purpose, and I will pause, give an example. Yeah, so the purpose is to connect those things together, like connecting your monitor through HDMI, connecting all your mice, your keyboards, external storage through USB, connecting the internet through your router through Ethernet. It's to connect the devices. So that's just about that. I've got a Word document open here. If I guess I have to write something down, I keep losing focus when I move it over. Right. A firm of architects stores plans for houses using cloud storage. Describe 2 advantages for the architects using cloud storage compared with traditional secondary storage. Right, first of all, you just go through your mind what cloud storage is. It's storage which is like not physical, you don't have hold of it, it's stored somewhere with the use of the internet. We call it the cloud because we just say it goes into the sky, but that's physically not what's happening. It might be travelling over Wi-Fi distances, I guess, if you like, but what it does is you connect to your router, it sends a signal to the server and it saves it there and you don't have to worry about it. So the advantage is it's kind of unlimited storage space. You don't have to worry about filling that up. I mean, if you've got a Google account and you've got the Google Docs, you can see just how unlimited space you've got. Like YouTube's another idea of cloud storage. You upload it to YouTube and it can be as big as you like, all the videos you've got. It's not stored on your hard drive. Advantage 2 of these architects using cloud storage is they all can access it anywhere they want with any digital device. They can be on road and they can just get the phones out and check the plans. They can check it if they went into a hotel room, so providing they've got the internet though. That's the big thing, they've got to have an internet connection for it to work. Some architects still prefer storage designs of traditional secondary storage. So secondary storage is anything which is not fixed to the computer, something you can remove or you add to later. So your primary hard drive, the one with your operating system, is not really considered your secondary storage, but you can have an external hard drive secondary. You can have flash drives, you can have CD-ROMs, you can have DVDs. So still prefer the designs on that. Give a reason why they might want to use cloud, not want to use cloud storage. Well, maybe they don't have the internet. So any advantage you've got there, just try and flip it on its head with a question like that. They just might not have the internet where they are, or the internet's really slow, and if they've got some really big plans, then they can't do anything. Right, below is a label diagram star network topology. It's a star because there's a switch in the middle or a router, and they're all connected but not connected to each other. Yep, okay, so, question must be down here. Other than the items labelled on the diagram above, so we've got switch, cables, computers, state the hardware required by every computer to connect to a network. Am I being stupid, or is it really that obvious? Is it the network card? All of those computers need a network card to connect to that, or an NIC, a network interface controller. I don't know if a network card will get you any marks, to be honest, because yeah, I call it a network card. Why not? Yeah, a network card or an NIC or something like that. I can't really think of anything else. Network adapter, maybe. Okay, yeah, I can't think of it. It's only one mark. Network card. Describe how a packet is transmitted from computer A to computer D. Right, I've not done packets for ages, but this is the general idea of a packet, right? A computer has to, 2 computers have to be involved, of course, and the first computer, so we'll call it computer A, has to, well, it kind of gets the address of this computer, and that's what the packet is. The packet is a series of data bits, and it's sent from computer A to computer D. So computer A will send the packet in the star network though straight to the switch. Now the idea of a star network is nothing's connected, everything has to go through this switch before it gets to this computer D, I guess. So the packet's sent to the switch. The switch will look at the address of that packet and it will compare it to all of these addresses stored probably on some kind of network manager database software, something like that, and it'll see if the address it's sent is on this list, and if it is, it'll forward that or send it to D's address, and then that computer gets it. But during this switch's time, it's checking it for viruses, checking that it's got all the packet data, usually sent in bits, 8-bit packets usually, things like that. So describe how a packet is transmitted from computer A to computer A. So computer A will get the address it needs, it'll send it to the switch. The switch will check whether that address is in its computer address list, and then that will send it to computer D, which receives it. 5 marks. Yeah. If you just wind it back and untangle what I just said, I'm sure I mentioned 5 different things there. Right, there are many different types of errors that can occur when developing computer programs. State the name of 2 different types of programming error described below. This is bread and butter stuff. There are 3 programming errors in computing. It's runtime. That happens when something breaks along the way, or it doesn't know what something is the program. So if you declare a variable which has not been defined in the program, that's a runtime error. It doesn't know what to do with it. There's logical error where all the program works, but you don't get the outputs you think you're getting, and the syntax error, and that's when you spell some of the key wording wrong in Python. It's not, if you're using Python, I'm going to use Python, so it's not so much you spelling things wrong like in the code you're writing and like strings you're writing, but it's spelling the code of the language, or the syntax of the language. It's why it's called a syntax error. It doesn't know what you're saying because it can't translate what you're saying. It's just like a language. If you go to a foreign country and you start talking like a really weird way of speaking, like, you know, Scottish people they talk English but they have an accent, and some people miss that translation. It's kind of like that really. It's just spelling it wrong, but you kind of know what you mean. You put a capital instead of a small letter. We know what it means as humans, but the computer can't read it. Right, so unexpectedly halts the program. So that's exactly what I said at the top of the board. That is a runtime error, because you don't know why it's quit. It's quit for a reason. It's stopped there, and then the program produces the wrong output. That's the logical error, because you know what's going in. You expect 2 out, but it's giving you 4 out. Another error can cause an error can result from incorrectly using the rules of grammar of the program. That's a syntax error. State when this error is detected. It's when something is the code can't be executed because it's spelt wrong, and that's, like I said before, it's not like if you're doing a string. It's like it reads it, but it doesn't know what it means, what you read, and even though perfectly well you put a capital IF, and in Python it's a small IF, and it goes orange on Python. So how would you say that for 1 mark? It just can't translate the code, because if you know how a compiler works and an interpreter runs the code line at a time, and when it comes to an error, it just kicks it out. So the error is detected when it can't translate the code, I guess. A software house encourages programmers to use libraries when developing its software. Explain why it is a good programming practice to use a library. Well, you don't call them libraries in Python, you call them imports, but you can have libraries. There are libraries. In C++, you use libraries all the time, and so let's explain why it's good programming practice. Right, 4 marks, I'll try and give 4 points. Point 1, the library is already coded for you, so it's going to save you a lot of coding time. You don't have to write new functions. 2, if it's in a library, it's probably been tested thousands and thousands and thousands of times, probably, because it's in a library. It wouldn't be in the standard libraries. Have been developed for years now, and people use them all the time. If you're using a library and everybody knows about it, it'll make code easier to read and for people to update and understand what's going on. If you were to leave your job and then the next person comes in and you're using a standard library, they'll be able to pick up right where you left off, which is good practice really. That is really good practice, because everybody understands that kind of way of programming. It's like if I went and did 4 I in range 10. If I did that, everybody understands that I here, even though a word has gone and capitalised it for me. Everybody knows that I is an iterator now. It's standard practice to write stuff like that. Standard practice. Fourth point. Time saved. Helps New users understand code because it's standard. It's already been tested, and libraries are often released by official documentation, I guess. This is off the top of my head. Like I say, I should have done a little bit of research before I launched into this. I'll say it's because the people who are writing libraries or releasing libraries are probably very good at what they do, so professionals, I guess. It'd be an idea to get the marking scheme. We'll have a quick check of the marking scheme after this. If the marking scheme's available, I didn't check. If a program calls a library routine that has not been loaded correctly, an error occurs. Name this type of error. If a program calls a library routine that has not been loaded correctly, an error occurs. It's a problem with the import. Let's just have a quick check. It could be in C++. You call it a linking error, but I don't know what happens in Python. Yeah, I think it's called a linking error. But in Python, never used the library in Python. I can't really tell you what it does. Right, so yeah, linking error. I'll have to double check that. I'll have to double check that. So below is a representation of a simple sine wave. Sine wave is sampled every second. Yep, 8 seconds long. And the amplitude is stored as a 4-bit binary number. So amplitude is 6 at time 1. Yep, and it's stored as 6. So if you can add up binary, that's equal to 1, that's equal to 2, that's equal to 4, that's equal to 8. 4 and 2 is 8. So that's 8 and that's 7. So that's 2, so it'll be 0, 0, 1, 0. 4 will be 2, 4, 0, 1, 0, 0, and then just fill it all in. So then you go to 4, 4 would be 5, 5 would be 1. So just fill that in, dead obvious stuff, but add your binary up. So if you don't know how to add up binary, basically you've got 8, 4, plus it's 7, 8, and then from left to right, that's 128, the first one. And that one would be 64, and it's halved every time, or you start at the other end at 1 and go yeah 2 and 1. So if 2, so time, I think we get, I don't know if you don't get this question, just send me a message if you don't get what I'm saying, and then I can clear it up, because I'm just trying to get through this as quick as I can. 2, so that you don't get bored as well, because it's boring to listen to stuff like this. I know, I've tried to do it myself once. So time 3 seconds is equal to 2. Yep, 2 is just all noughts, but if it's doing it in 4 bits, it's just these back 4. So it'll be 0, 0, 1, 0. 4 is equal to 5, so it's 4 and a 1. So 0, 1, 0, 1. 6 is 6, so 4 and a 2, it's already here 6, so yeah, they're already, so you can just copy that to there. 7 is 5, we've already had 5, copy it over, use the space to show you for your workings if you need to add the numbers up, but it's 5 marks, so I don't know how you get 5 marks in that. 1, 2, 3, 4, 5, maybe you have to get, I don't know how you did mark that. State the number of bits required to store the binary data for the completed table. Bits required to store the binary data. Right, well there's 4 bits per cycle, and then there's 8 cycles. So it's 4 times 8, 8, 16, 24, 32. You need 32 bits to save all that, and if you want to prove it, you can count it 4, 8, 12, 16, 20, 24, 28, 32. So 8, 16, 24, 32. It's 4 times 8. Right, convert your answer from BI to bytes, so it's 32 bits. To get it into bytes, there's 8 bits in a byte, so it's 32 divided by 8. That should be 4. So it's really the number you did, 4 times the 8 bits to give you 32 in it. So 4, the answer for that is 4. Taking a sample every second produces a very poor quality sound. Explain how the sample rate could be altered to improve the quality. So just, is that a trick question? Taking a sample every second produces a very poor quality sound. Because sound is generally sampled at 44,100 times a second. In hertz it is that. So being sampled every second is once every second is terrible. So explain how the sample rate could be altered to improve the sound quality. Just up the just take the samples more often. That's it. Just it's difficult to understand what that's asking you. Explain how the sample rate could be altered to improve the sound quality. Just take more samples. Is it really that? Oh, I don't know. But yeah, I think that's the answer. I can't think. Yeah, that's the answer. But then, if 10 samples, look at that. If 10 samples were taken every second, say the effect of the size of the file, right? It's going to get bigger. It's as simple as that. The more samples you take a second, the more data is saved, so it's going to get bigger. Calculate the number of bytes required to store the data for the wave when 10 samples per second are taken. You must show your workings, right? So with 2 max, so you're going to go 10 times 8, because there's 10 samples per second now, times the 8 times you're going to sample it, times by 4. So that's 10 times 8, which is 80, times 4, which is 8, 16, 24, 30, 320. So that one's going to be 320. And then number of bytes, it's 320 bits, divided by 8. 320 divided by 8 is 4, which is all 40. So 40. So you're going to have something like 10 times 4 times 8, something like that. And then put that to 320 bits, because you've got to work everything out in bits to begin with. And then 320 divided by 8 is 40 bits. 40 bytes, sorry. Yeah, that'll do. Convert the denary 162 into hexadecimal. So first of all, you've got to get 162 worked out, which I believe is, well, 162, if you know how to do hexadecimal, 128, so there's got to be one in 128. Then we've got 128 off 162 is 34, so we need 1 in the 32 and we need 1 in the 2. So that would be the binary number for that would be the binary number for 162. Put it into hexadecimal. You split it into nibbles, which is 4 bits. Split it into nibbles, which is 4 bits. And then there's a golden rule. 10, 10 is 10. Well, this is how I do it. I've never heard anybody else describe it like this, so sorry if I'm confusing you. 10, 10 is always 10. You know 10 is A. And then 11 is 10, 11, which is B. So that should be A, that bit. And then, oh sorry, you should really do it from the right hand side. So you split it up into nibbles like we've done, and it then goes 1, 2, 4, 8 like that. But when you're doing it in nibbles, it splits to hexadecimal, sorry. It goes to 1, 2, 4, 8 again. It forgets this naming convention here. So that would be 2. And this would be A. 10, 10 is A. So the hexadecimal code for that would be A2. There is another way of doing it, and it's using your 16 base. So 16 to the 0, 16 to the 0, superscript, where are we? So you can have 16 to the 0, you can have 16 to the 1, and you can have 16 to the 2. I don't think it'll ever go higher than that in GCSE, because 16 to the 0, you know, is 1, 16 to the, you know, is 16, but it's not 26, what the hell, and then that is 256, So what you can do is how many times does 16 go into 162? You'll find out that it's 10. So it's 10 with 2 left over, and you know 10 is A, and that's how you can do it a little bit faster. That's a nice way of doing it. If you don't know that, I'll explain it again if you really must. Because in hexadecimal you can't have anything over 10. It's got to be represented. If it's over 10, it's got to be represented as a letter. Anything under 10, it's got to be represented as a number. So A2 would be the answer. Convert the hexadecimal 1E to denary. So 1E is basically you put E into this, which I know is E is, I know F is all ones. Yeah. So all F is all ones, and I know E is just one bit less because it's E. So that would be the binary for E. And 1, we know it's just a 1 in there in hexadecimal. 0, 0, and then you add it all up, which is 16 plus 8, which is 24, plus 4 is 28, plus 2 is 30. Is that right? 30? Let's have a look. 28, 30. Yeah, it looks right to me. Whoops, 30. Yeah, that's the binary. You'd have to go that way around, or you could do it using a 16 base, because 16 ones are 16. Can you see you got one here? 116 must go into the 1, and then E is 14, you know that. So 16 plus 14 is 30 if you want to do it that way around. But I always do hexadecimal that way around. If it's 2 bits like that, two nibbles, sorry, 8-bit representations, I always do it that way because it's really quick. You know that's 1, you know that's E. So away you go with that. So the answer to that question is 30. The answer to that is A2. Yeah, right. So complete the truth table. Right, A or B. So in a truth table, in an OR circuit, sorry, you know that 2 inputs go in, and either one of them have to be on for you to get an on. So I'll just do this dead quick. So 1 on a 1 would equal a 1. A 1 and a 0 would equal a 1. Sorry, a 1 and a 0 would equal a 1. A 0 and a 1 would equal a 1. And a 0 and a 0 would equal a 0. So that's what you'd put in the AB, that one. I'll just zoom in on this a little bit. That's what will go in the AB. All because an OR circuit is either one of them has to be on to get a 1. And then not A or B, you literally just reverse that. So not A or B. In proper coding, it looks like this: A or B. That's what it looks like professionally in a circuit, not A or B. And it's just like maths, you do your brackets first, A or B, not at all. So if it's 1 here, it's going to be a 0 here, it's going to be a 0 here, because it's literally the reverse of what you're looking at from the last column, and that would be a 1. So that would be column 1, 1, 1, 1, 1, 0, and your final column will be 0, 0, 0, 1. 4 marks, you probably have to get them both right to get a mark. Right. Describe 4 features of the operating system when providing a graphical user interface on a personal computer. Right, so a graphical user interface on a personal computer. Right, Windows uses a system called WIMP, and it stands for Windows, let me not get this wrong, Windows icons, menus, and I think it's pointers. So it's looking for feature 1, which is Windows. Windows help you to open up multiple things at once. They help a user use 2 documents, save documents, copy and paste from documents, because you're talking about the operating system when providing a graphical user interface on a personal computer. So you can see things, you can transfer things. Icons, they let you put the shortcuts, if you like, to the programs on your computer, so you don't have to keep going into the folders to find them. So feature 1 would be Windows, to see files in folders, to see programs in folders, whatever you're saving, shortcuts. Feature 2 would be icons, and that's to easily open and run programs without having to go into things like that. Feature 3 would be menus, so everything's compact. You can see it, like if I do this now, there you go, it's done this way now in Windows. It's more of an iconic based system, but you can still get your menus. You can see this is a menu, isn't it, really? All done in a alphabetical order. Look, I can see if I'm looking for my Forza game, there it is. If I'm looking for Killer Instinct, because that's a good game, Halo and all these things, Ninja Python stuff, whatever. Yeah, menus. Pointers, look, I'm doing it now. User interface, I can see where I'm about to click. Everything highlights over the windows. That's again the windows. It shows you where you're hovering so that you know what's going to click next. Icons, look at all these icons. Menus, look at all these menus. And that's all controlled by the operating system when it does things like this. And pointers, you're looking at it right now. Pointers just like select different areas of the screen. You can see. Yeah, I think that's it really. I think Windows when that's what you need to remember for that. Alright, below is an algorithm. This is where we get good. I love stuff like this. Right, so M is an integer. This is like completely ridiculous pseudocode. I've never seen it written like this before. This is very basic. This is barely pseudocode. So M is an integer, P is an integer, I is an integer. So MPI is all integers. Start the main prog. That is obviously like there's some pseudocode to say like the code is saying input M. So whatever you type into E, if we put a 1 in there, for I is equal 1 to 4. P, which is an integer which has not been set, is I, which would be 0, 1 on the first pass, times M, which we said would be 1. So 1 times 1 is 1, print 1. Then I had become 2. So P had become 2 times 1, which would be 2. That's what I think it's going to ask you before I even read the question. N4. So write down all the outputs produced by the algorithm when the input of M is 3. Write this stuff down when you are doing this, because it's easy to get confused. Right, so if it starts at 3, M is 3, that's the first line of the program where something actually happens, apart from the assignment of regular pseudocode would look like this though. M, a backward arrow, user input, regular pseudocode would look like that for that, sorry. So for I is equal 1 to 4, so if I is equal to 1, so P is equal to, and this will be on the first pass, 1 times 3. So the first one, the output, is going to be 3. On the second pass, I becomes 2. So P is going to be equal to 2 times 3, which is 6, I believe, in simple maths. So the output is going to be 6. On the next pass, I is going to become 3, and I think you can see the pattern. It's going to go 3, 6, 9, 12, because you've got to go all the way up to 4. Make sure you write 4 down, and that's when it stops, because it's reached 4. So you should have 4 outputs: 3, 6, 9, 12, 1, 2, 3, and 4. If that pseudocode is anything to be gone by, you'd have to check the marking scheme, because in Python it starts at 0 and going up to 4 would produce 0, 1, 2, 3. It wouldn't actually produce 4, but I'm not sure. Yeah, it doesn't. That seems obvious enough to me. It starts at 1 and it goes all the way up to 4, because they'd use another word like less than 4, and then you would have to go up to 3. Right, so let's have a look at this. So when let's make sure you can keep seeing this. See, I've got it's going off onto my other screen, so I can't set the focus. Total is total what? Mean is that, count is that. Right, I'm going to guess before we do anything here that it's going to ask you to identify what variable these should be, or not what variable, what data type these should be. So set total to 0. So total at the minute is an integer, but I'm seeing this mean here. That's going to be divided by, so that's going to be a real or a float. Count is always an integer because you count up in natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So count is 0, that's an integer at the minute. Count plus 1, see, so that's going to be an integer. I've not even read the question yet, so I don't even know if I'm doing this right. Total plus count, that would be an integer, until count is equal to 20, so it's going to do that 20 times. Output, the total is total, and then the mean is total divided by 20. So if your total is 21 and you divide it by 20, you're going to get a reciprocal, aren't you? So mean has got to be a floating point number, a float or a real, I think that's what you call them. Right, so let's have a look. The algorithm has 3 variables. Yeah, okay. Right, state given a reason for each, the most suitable data type. We've already done it. So if you want to skip to the next question, but I'll do it dead quick. Mean, that's going to be a real reason because you're having to divide something, and you might have to divide something which leaves a remaining number. Count, it uses natural numbers. It goes up through a sequence from 1 to 20, see? So there's no need for a reciprocal for that. Some computer language has a local static variables, C++ being one of those, that can be declared inside a function. Describe the difference between a local variable and a local static variable. That's an excellent question. Okay, that is computer science. Right. So I don't know if you know anything about object-oriented programming, but static variables, if you look around the window and catch it, this is where a derivative of one of my usernames comes from, because it always retains its value throughout the program. So if you run a function and I is equal to 0, and by the end of the function it's equal to 4, it's going to be 4 for the rest of the until the program literally quits out and memory is lost, unless you're saving that ROM and it reads it in every single time you open the thing, like a web tracker or something, I don't know. But it's never going to lose its last value, a static variable. So what's the question? Describe the difference between a local variable and a local static variable. So a static variable never loses its value throughout the duration of the program, where a local variable, they're defined like this. So if I went def func like that, and then I went I equals 0, return I. If I did that, every time I run that function, I would always be set to 0 every single time I run the function. But if I define it as a static function, it's called a static cast in C++. If that ends, so I plus equals I, it will be 1 on its first pass. Plus equals 1, sorry. It will be 1 on its first pass, and it will be 1 for the rest of static. It will be 1 for the rest of the program. But if you don't have that, it will reset itself to 0 every time you call the function. So the difference is one will return the value where the other one doesn't. Right. Command line interfaces, CLI, are often used in the computer industry. Well, they are. Describe you might use a CLI. So a computer programmer will definitely use a CLI. If you're a Linux programmer, you use CLI every single day. Describe you might use a CLI and give 3 reasons. 3 reasons. Jesus, this is going to push me now. Who might use a CLI? A programmer. Why? Because we know better. Don't write that. Right, reason 1. Because I know CLI are the fastest interfaces out of all of them faster than this rubbish. Look at all this it's got to load. Look at the lag on that. I mean, this is a really, really fast computer. And even that, you can see the transition loading in and things sliding. I mean, maybe if you turn that off it wouldn't do it, but you can see, like, if I search for something, let's search for something called doc. Well, it's quite fast in it because it's a bloody quad core 4 gigahertz computer, right? So it's faster usually, but you're not allowed to say faster. You've got to qualify your answer. It's faster because it doesn't have any bulky windows to open and commit to memory. Doesn't do that. Reason 2. Well, alright then, your operating system for Windows, I think it's about 2 or 3 gig, maybe 10 gig, who knows, I've never even checked. CLI interfaces will be next to nothing. They won't take any storage space up whatsoever, and that's why they're so fast, because they're like, it's literally like assembly code. It's like instructions. You don't have any of this clutter in the field. So if it's less on the processor, it's probably less on system resources as well, I reckon. I've never checked this though. I've never actually I've never really looked at the overhead of Linux, but I'm going to say it will be far better on your RAM, because if you use your if you open your what's it called now, your Control Alt Delete task manager, you can see that all these programs here, you can see like the memory is being just by opening up simple programs. You can see it's caning my system resources up to quarter of what's allocated to it. So third reason, yeah, it'll not have a drain on system resources. Image files can be stored on a computer using lossy or lossless compression. Compare lossy and lossless compression in terms of their effect and quality and file size. Right, it's simple as this. Lossy loses information over its compression, but it keeps the file sizes super small. But the quality is lost a little bit. Lossless loses absolutely no quality, but you will sacrifice some larger file size. But it's still compressed. It's still smaller than the actual raw data, but lossy would compress more because it loses data. It gets rid of the least significant bits of things and stores it up and does its best job at putting them back when it uncompresses it. And lossless literally puts it back as you found it. Give 3 reasons why image files are compressed. Right, to save space on your computer, file sizes are often now in the megapixels, aren't they? Like even a regular phone picture is up close to, like, sometimes a few gigabytes. If you look at those football spinning panoramic views they do, they're like 30 gig a piece. Reason 2, files compressed so that you can send it over an email. There's no way you can send a 30 gig file over email, but if you use the strongest lossy compression over something, you probably get it down to maybe a few hundred megabytes, and I know that'd still be slow, but it's better than sending 10 gig. And then just off the back of that, it's quicker to download as well. If I had a super quick computer what could transfer 30 gig in a couple of seconds, and then the person who's going to read that email or download that file, he might not have a fast internet connection. He's going to have to download 30 gig. So you can press it for download, for taking up less space on your computer, and to send over network protocol, internet, email, things like that. Give 2 examples of the metadata that might be stored with an image. Right, metadata is all the data about that file. So if you just think of an image on a computer, what have you got? You've got dimensions, you've got color depth, you've got God knows how many do you need to? Color depth and resolution and dimensions. I've said that, I think. It might have like some words with it, like maybe like the device it was taken from, the time it was taken, the date it was taken, things like that. Small business stores data as its customers on a computer system. This is going to be talking about databases, I bet. Let's go. Describe how the business ensures that only... No, it's not. Describe how the business ensures that only employees can access the network. So let's highlight that, because that's a point. We need to make sure in our answer we talk about that. Describe other security measures the business will have to have in place to limit how data is accessed by its employees. So describe how the business ensures that only employees can get access to the network, and security measures that the business will have in place to limit how data is accessed by the employees. There's two questions there. You've got to be really careful on this. It's a 10-mark question. So we need about 5 points, I reckon, 4 or 5 points minimum. So the business thing, right, so we'll do this bit first. So let's keep our answer structured, because I'm sure the marking scheme will say something like, you know, having so let's keep our argument structured. So first point is access the network. So you're going to need, like in a school, you're going to need usernames and you're going to need passwords, and so that's our employee can access the network. You're going to have your own username, your own password, and your own user privilege, probably. That's the only privilege. That's the only thing. How do you spell that? Privilege. Oh, I didn't even know. I'm terrible. So describe. So there you go. That's what you need for employees to access the network. Those 3 things. So explain it. So you'll say the business will ensure that only employees can access the network because they've given their own usernames and passwords, which in turn will have a user privilege status. So describe other security measures the business will have to place a limit on how data is accessed by employees. You can go off the back of that. They'll have user privileges. They'll have you could call it permissions, I guess, to go onto certain places of the drive. You'll have the ability to limit how data is accessed. So you're talking read and write. These words are the same for nearly all the exams. I mean, I'm practically not even answering these questions. I'm just pulling keywords from experience, really. So read and write. Privileges, like some documents you can only read, some you were not allowed to overwrite them or write to them, some, yeah, things like that. So you can just explain that. So there's about 5 points, which is good. And then the business encrypts their data so it cannot be used by hackers even if they gain access to the network. Describe how the data could be encrypted and decrypted by the business. Right, if you know anything about encryption, all encryption methods, they have a key which deciphers the encryption. So the easiest one I can think of is a Caesar cipher. So if you've got A, B, C, D, E, F, G, H, I, J, oops, R's not in there. So what you do with your Caesar cipher is you give it a key of 3, and basically you shift A3 to the right. So A now comes under 1. So 1. So I'll do it the same way I did it before by tabbing. So that's going to be your key, that 3. So A would be moved 3 places to the right. So 1, 2, 3. So that's your A, and that's your B. So that's your Z. X, Y, Z. There you go. I have to do the rhyme. There you go. So if I wanted to spell out Baz, it would be E, D, C. Yeah, and that would be the encryption because I've shifted the A3 to the right. So the business, describe how the data could be encrypted. So you need a key, and then those keys follow this sequence, I guess. So what's the best word for a sequence? An algorithm. So it follows an algorithm. And if you've read a book like, if you read, there's a guy called Jeffrey Deaver. If you read, and what's his name, Dan Brown, you might find some interest in these books. Jeffrey Deaver has done a book called The Blue Nowhere. You might like that. It's about social engineering. Broken Window, I think it's called. I'm in no way affiliated by this guy, but Dan Brown, he did it's a brilliant book, Digital Fortress. It's all about viruses, hacking, encryption. It's brilliant. You might like that, Digital Fortress. It's good. Right. It's really good. In fact, I've got the book. If you get someone to come and ask me, I'll give it you. Anyway, describe the procedures the business should have in place to recover data from a natural disaster, so earthquake. Explain how data would be recovered after the fire destroyed the hard disks holding all the data. So, business recover data from natural disaster. So, I think we're talking about big storage devices here. So I don't know if you know, but servers are actually stored to magnetic tape, if you didn't know. So you'd have it all backed up to magnetic tape, or you would have saved it all to a cloud. Going back to one of the questions above, you'd saved it all to the cloud, so then you can just do it. But a big business with data what it needs, those backups should be done every night, and they should be taken off site by your network manager. That's what he's paid to do, and he keeps them for, let's say, a 2-week cycle, and then the second one gets brought back in, or the 14th day one just gets rotated in a big rack, like a big like patch B, if you like, and you pull them out, and you take them in and you overwrite that one with today's data. Some companies keep backing up for years, but you're talking like massive amounts of data. You're talking massive amounts. Procedures of the bank. I don't really know. I'm having cloud storage and digital tape, magnetic tape. So I've only given 2 points. I give a few there. Encryption. So let's have a look at that again. Access and describe the data could be encrypted and decrypted. So encrypting, that's how you encrypt it. You use a key, and then you decrypt. You need to have an algorithm and the key. You need to have the key to decrypt it. That's just a bit of extra. Explain how the data will be recovered after a fire destroyed the hard disks. Yeah, just cloud storage, magnetic tape which should be backed up. Yeah, and any other storage media you might back it up on. But if it's talking about a big business, like I'm trying to think what happened to that company. What was it called? 3. It had all its data like altered, and it's now running around like headless chickens trying to get all the data back to like a month ago before this hacker got onto it. I'm trying to remember what I read about it, what they had to go through. Anyway, next question. Oh, there you go. It's the end. Oh, that was nice. What time are we on? 20. Let's have a look at my timing. Oh, it took nearly an hour, but there you go. That's all the answers. You can read back through it if you like, but yeah, just get over my prattling, and that's how you answer the question. But just ask questions if you want to clear any more of it up, or go into a bit more depth, maybe throw in some different questions, what they might ask you instead. We've got a month, so plenty of revision to be done. Yeah, thanks for listening.